Form the polynomial with zeros 2, 1, 0, and negative 5 and degree 4. So we know what the zeros are, and from the theorem about real zeros, we know that if there is a 0 at r, then x minus r is a factor of the polynomial. So since we have a 0 at 2, we know that x minus 2 is a factor. I'm going to put x minus 2. We also know that x minus 1 is a factor. X minus 1. We know that x minus 0 is a factor, but we don't need to write minus here. We can just put an x to simplify it. X. And then we know that x minus negative 5 is a factor. But I'm going to write x plus 5 because that's simpler. And it's the same thing. So x plus 5. Okay, so now we also know that the degree has to be 4. Since there are 4 zeros, each one of those zeros wouldn't be a 0 if the degree wasn't at least 1. And since the total degree of the function is 4, and we already have 4 accounted for, we know that we don't need to double any of these up. So the multiplicity will be 1 for all of these zeros. Okay, we have a similar problem right here. It's giving us the zeros, negative 3, negative 1, and 6, and it's also giving us the multiplicity of each one of these zeros. Thank you. So I'm going to write it, same thing, I'm going to do a function, f of x equals, and since negative 3 is a 0, I know that x minus negative 3 is a factor. But I'm going to write x plus 3. X plus 3. And since the multiplicity of that is 1, we don't need to put an exponent up here, because 1 is the assumed exponent if you don't put 1. Okay, for negative 1, x minus negative 1 is the same as x plus 1. X plus 1. And for this factor, or for this 0, the multiplicity is 4, so I'm going to put an exponent of 4 on this factor. 4. And finally, x minus 6 is a factor because 6 is a 0. X minus 6. And we know the multiplicity of this factor is 2, so I'm going to put a 2 right here. Okay, now it says the degree has to be 7. This is redundant because it specified the multiplicity for each one of these factors, so we already know the degree has to be 7, but I wrote it anyway. Because the multiplicity has to be 1, 4, and 2. So we have 1 power of x, 2, 3, 4, 5, because we're adding 4 more right here. And then 2 more makes it 6, 7. Since we knew the multiplicity, we knew the degree. So this one's done too.